Okay, so yeah, I use VS Code for the time being, but soon it is going to be changed. Okay, so the thing is, I'm trying to write OS in Rust. Not that fully functional one, but just to learn Rust, because I come from embedded background and I need to learn Rust. And this is not the best approach because I can start with embedded in Rust. That would be pretty easy, but still, there is no reason why I'm doing this. This means why I'm writing OS to learn Rust. Like, completely doesn't make sense, and it does not matter. So let's see. Feel like it shouldn't be too difficult, but let's see. Okay, so the thing is, there is this build your own, not the there is this GitHub where there are a lot of things that you can build. So if I st there should be write an OS. Yeah, so this is the blog that Phil has written, and it's pretty detailed. I've already done a couple of things, but that was a long time ago, so I have gotten everything almost, and it's like I'm starting from the scratch. So just to record my own progress, I'm streaming while I'm coding. And one more thing, it keeps me organized in my thoughts. Otherwise what happens is I'm writing some code and my mind is somewhere else. After 5 minutes into the process, I am not doing anything. So let's see if this stream can help me focus. And I'm really hoping that my sound is good. It is night time, so there shouldn't be any disturbance, but you never know. That's how it is in my locality. Boy, this feels good. Okay, so should I send a link to Discord in case someone wants to see? Most likely nobody cares, so whatever, I'm just gonna write it. Okay, so the first thing is, okay, this thing. So I have already made a GitLab repository in the same name. Cool, great. So just a basic repository, nothing fancy. Cool. 5421881. Great. I'm a little bit sick. Okay, so as you can see, this I made it already yesterday, and there is nothing. This is the dummy readme that GitLab gives you, and here is the source code. Wait a minute. We're good. We are good. We are good, right? It should be. So as you can see, there is nothing much going on here. Oh boy. So just a storage, so everything is like up to date with my this one. What is this? This one doesn't matter. So if cd fetch cr cargo build. It should be okay. So we are ready to do the thing. Let's start with this. Let me give you the overview of this block. There's this like sections, like very well divided, and with each section you move forward with your learning in OS as well as in Rust. This is the best part of these where did it go? These build your own thing. Like most of the articles there, or the blogs there, or should I say resources there, have been written in a way you can use them to learn the thing that they are building, or you can use them to learn the language you are building that thing in. So this is the best part. Like it is going to teach you the Rust language as well as the OS. So you are indeed learning two things at a time, but the blocks are teaching you both things at a time. It is going to be challenging, but let's see. Pre-string Rust binary. So as I said, I come from embedded background, so I already know a couple of things, and I'll try to explain as much as I know. Okay, so this thing is free Rust binary. So I'm just cutting down to the chase. I'm not gonna read all of that. Of course, I'm gonna read when I don't know something. You get the point. It's like pretty old, I guess. It's showing the structure of language, as I said. Like it is teaching you the language itself, what the post describes necessary steps to create free standing Rust binary and explains why the steps are needed. See, it also explains like steps. If you are just interested in a minimal example, you can jump to summary. This is outstanding job in writing this blog. So see the standard library. So every language, as you know, has standard library. So we are first disabling that, because standard library assumes there is an OS, and we are writing OS, so there is no OS. So we cannot build on the assumption that the piece of software we are using comes with. So like this is, let's start with here. So here I have bare minimum, and so disabling the standard library, what does that mean is I am not going to use any standard. So the Rust has two parts, the core language and the standard library. The core language does not assume that there is some OS in the background, right? It just works. It just depends on the core language. That's like cool. But the standard library assumes there is a core and there is an OS in the background, so as a dependency. So we don't want that, because we are writing OS itself, and we can tell code compiler that we are not going to use any standard library by using this. And I'm not very good with Rust. I don't even know Rust, if that matters. I'm just gonna copy paste this couple of things. So stt. So as you can see, this is going to give me some problems. Cannot find macro println in this scope. See, the println itself assumes there is an OS. Because it prints onto the screen or standard output to be precise. But if there is no OS, there is no standard output. In embedded, you have the hardware, you have the MCU, you don't have anything else. So where is the standard output? There is none. There is no screen, no keyboard, nothing. No files, no concept of files. There is a simple hardware, plain as 0 ones. That's all. So all these things that works in OS, they are not going to work in. So I can just delete it and it should work, right? I just see cargo bit. Okay, so it doesn't even compile. So it is asking for things like panic handler. So what is panic handler? Let's see what does the blog say, because I know I can, instead of me explaining this, let the guy who wrote the blog, the very good blog, do that work. So when I do this, it's an attribute. Okay, see, println error, cannot find the same thing, we paste. Okay, so when we build, now the compiler is missing a panic handler function and a language item. I did not get any error with the language item, did I? Yes, I did. So it is missing the language item. See, he explains very well. Panic handler. What is a panic handler? Defines the function. So panic handler attribute defines the function that the compiler should invoke when a panic occurs. Standard library provides its own panic handler, but in a no standard environment, we need to define it ourselves. See, a lot of things we are going to do ourselves. How do I do that? So use this panic in this code, packages, and whatever this thing. This function is called on panic. Okay, so you can define any function, attribute it with this, and it becomes a panic handler. Okay, so let's just do that. Define a function called PNC info. It takes a reference to panic info, and it never returns because p loop, right? Loop, yes. But then attribute, how do I define attribute? Panic handler. It cannot find panic info or write that code thing. Rest core library, just make it a little wide. It should be fine. Is a dependency free, right? Foundation of Rust standard library. Rust core library is the dependency free foundation of Rust standard library. It is the portable glue between the language and its library. Portable glue between the language and its libraries, defining the intrinsic and primitive building blocks of all Rust code. It links to no upstream library, okay, no system libraries, and no libc. Very strictly speaking, there are some symbols which are needed, but they aren't always necessary. The core library is minimal. It isn't even aware of heap allocations. See, I didn't know that. Nor does it provide concurrency or I/O. These things require platform integration, obviously, and this library is platform agnostic, right? How to use the core library? Please note that these details are currently not considered stable. Alright. This library is built on the assumption of few existing symbols. Memcopy, memcompare, memset, strn. These are core memory routines which are often generated by LLVM. Additionally, this library can make explicit calls to these functions. Their signatures are the same as found in C, and C is so universal. It is too good and too simple. Just one. These functions are often provided by libc. Happy Diwali, boys. Happy Diwali. But can also be provided by compiler built grades. So these are provided by system libc, so you do need libc, but it can also be provided by compiler built-in grades. What does that mean? A compiler built-in grade. So okay, grades. It's great. So it's great. It's great that okay. Rust begin panic. And this function takes 4 arguments. String to U32. These 4 arguments dictates the panic in message, the file at which panic was invoked, the file at which, okay, and the line and column inside the file. It is up to the consumer of this code library to define this panic function. It is only required to never return. Okay, this requires a lang attribute named panic impl. It is only required to never return, that what I understand. This requires a lang attribute named panic. Whatever. Rust app personality is used by the failure mechanism of the compiler. This is often mapped to GCC's personality function, but grades which do not trigger a panic can be assured that this function is never called, and the lang attribute is called app personality. The lang attribute is called app personality. The lang attribute is panic implementation. Panic handler. What is this? Will it work? Cannot find attribute panic impl. This is scope. Panic. What is this? Panic support in the standard library. This I understood, and right now I'll read it. What is panic? Okay, this is a module. Panic support in standard library. Panic info. A struct providing information about a panic. Structure is passed to a panic hook set by the hook function. Panic info structure is passed to a panic hook set by the set hook. So what does set hook does? Set hook. Okay, so standard panic set hook box new panic info. Critical system failure. I call this set hook takes we are allocating on heap. Okay, this on heap we are setting this. Box is basically telling the compiler that we want to allocate whatever inside here into the heap. So that's what the box is for. So onto the heap we are saying a closure. I mean, it makes sense, then sort of doesn't make sense. Let's just forget it. You deal with the data. So, okay, so now I have my panic handler, which the compiler complained about. Now this app personality, I'll just cargo build and see what happens. Obviously it is saying language item required but not found app personality. Okay. What does the block say? Contains the file in the line number where the panic happened and the optional panic message. Okay, so it also contains panic message. Nice. The function should never return. So it is marked as diverging function by the sticker. App personality language items are special function and types that are required internally by the compiler. For example, the copy trait is a language item that tells the compiler which types have copy semantics. When we look at the implementation, we see it has the special lang equals to copy. For the custom implementation of language item is possible. It should only be done as last resort. Okay. Upper language item marks a function that is used for implementing stack unwinding. So what is stack unwinding? Like I can go on to this, but I sort of stack unwinding. So call stack, we are all familiar. We all should be familiar if we are programming with the call stack. It's a stack where the memory allocates whenever a function call happens, right? So, what briefly speaking, what does the unwind means? As you call a function, as you keep on calling a function. Okay, here's the diagram. So the called function stack frame is perfect place to store the function's automatic variable. So what happens that this is your call stack. Top of the stack, activation record for main, activation record for F with the code. Okay, so this is the code. See, main app. So earlier there was a main, then this is for the because in main we called app. Earlier this was main, then we call f in the main, then there is some stack frame for the main, for the f, and so this becomes your call stacks, and whenever some error happens then this stack has to be unwind, and it just app personality language marks a function that is used for implementing stack unwinding. So you can implement your own stack unwinding by using this. By default, this is unwinding to run the destructors so of all live stack variables in case of a panic. This ensures that all used memory is freed and allows the parent thread to catch the panic and continue execution. Unwinding, however, is a complicated process, of course, and requires some OS specific libraries like libunwind on Linux and structured exception handling. So we don't want to use it for our operating system, of course, so we are going to disable it because why not. This is how we disable it in the development and in the release. We just want to abort. Do this in the cargo.toml file. Okay, cargo.toml file. I just what was that? profile profile dot development abort. Okay, so now if I do cargo build, it should work, right? If info is in intentional prefix, okay, no problem, sir. Cargo build, but requires start lang item, so it also need another language item. Okay, start attribute. One might think that the main function is the first function called when you run a program. Well, I can tell you that's not the case. However, most languages have runtime systems. But Rust does not have a runtime system, mind, which is responsible for things such as garbage collection or software threads. Who's that? Wait a minute, boys. Man, I have to reply to this. Wait a minute. एक सेकंड बॉयज, एक सेकंड. हाँ, great. I don't have any. एक मैच की तो बनाई थी, बाकी yes. So start attribute, software threads, go routines. This runtime needs to be called before main since it needs to initialize itself. In a typical Rust binary that links the standard library, execution starts in a C runtime library called CRT0. Okay, I did not know that. CRT0, C runtime 0, C as a runtime, which sets up the environment for a C application. Ah, right, I remember from that book. Right. This includes creating a stack and placing the argument in the right register. This includes creating a stack and placing the arguments in the right registers. Oh boy. The C runtime then invokes the entry point of the Rust runtime. which is marked by the start language item. Rust only has a very minimal runtime, which takes care of some small things such as setting up Stack Overflow card, printing a backtrace on pen. The runtime then finally calls the main function. Our freestanding executable does not have access to the Rust runtime and CRT0, so we need to define our own entry point. Implementing the start language item wouldn't help since it would still require CRT0. Instead, we need to override the CRT0 entry point directly. What the fuck? That's so good. To tell the Rust compiler that we don't want to use the normal entry point chain, we add this. I'm telling boys, I have gone a little bit far into this blog, so I know things are very advanced and very interesting. It's just that it's been 7 to 8 months, if I remember correctly, the last time I touched this blog. I have problem in speaking, but this is so good. God, feel good, right? So we just tell the Rust that there is no main. Don't want to use the normal entry point chain. To tell the Rust compiler that we don't want to use the normal entry point chain, we add this attribute. Alrighty. Okay. So we say we don't have a main, bro. Cargo build. Could not compile to due to previous error. Okay. Error pe error. Nice. Okay, so it is linking with C. Failed. Some extern, what does it say? Not LC all equals to whatever this is. And then it is saying in start function undefined reference to main. Oh, okay. See, this is the linker. It is saying so. Standard library has this symbol, or it expects this symbol, but it has this function, and inside this function it is looking for main. Show branch. Hold it. Yeah, I'll see. It is saying undefined reference to main, undefined reference to libc start main, and then some external function couldn't be found. Some native libraries may not be installed or have their path specified. Use the flag to specify native libraries to link. Use cargo Rust link lib directive to specify the native library to link with cargo. Whatever that is. Interesting. You might notice that we remove the main function. The reason is that main doesn't make sense without an underlying runtime that calls it. Instead, we are now overriding the operating system entry point with our own start function. Alright, so it was looking for this thing. I just override it. Main function is never. Boy, have you ever seen this warning? Main function is never used. This is poetic. So what we were doing, own start. So your operating system entry point with our own start. So we are replacing, if you remember, we are replacing this right? Maybe I'm wrong, not exactly this, but something along this line. I don't know, man. I'm just don't know it. So we are saying append how do I do that? I just don't know it. I don't know Rust. So we are saying it is public, extern, follows the CABI mention, then it's a function. Okay, so let's just start with the function. What do I know about this start function? It returns never. But this has to be public because some other thing is going to call it, and it has to be CABI extern C, right? And we don't want its name to be mangled. And LOP. Oh, let's give it a shot. See how cargo build. Hallelujah. Still no luck. Some function we disable name mangling to ensure that the Rust compiler really outputs a function with the name list. These things without the compiler would generate some cryptic text. Okay, so I know the name mangling, the calling convention, that's why we use it doesn't return anything. So instead of returning the entry point, you'd invoke the exit system call of the system on what? Whatever return type means that a function is diverting that is not allowed to ever return. Okay, and this is required because the entry point is not called by any function, but invoked directly by the operating system or bootloader. So instead of returning the entry point, should invoke the exit system call of the operating system. It's a Wikipedia article. In our case, shutting down the machine could be a reasonable action, since there is nothing left to do if a freestanding binary data. So for now, we fulfill the requirement by looping endlessly. When we run cargo build, now we get a linker error. Alright. Linker is a program. See, it also explains. The linker is a program that combines the generated code into an executable. Since the executable format differs between links, each operating system has its own linker that throws a different error. Combines the generated output into an executable. Generated code into an executable. Combines the generated code. So you compile, code gets generated, then it's convert that into an executable. Since the executable format differs, of course, yes, makes sense. The fundamental cause of the error is the same. The default configuration of the linker assumes that our program depends on C runtime. Everything just depends on C, which it does not. That our program depends on C runtime. Okay, to solve the error, we need to tell the linker that it should not include the C runtime. We can do this either by passing a certain set of arguments to the linker or by building for a bare metal target. Building for bare metal target. Bare metal. By default, Rust tries to build an executable that is able to run in your current system environment. For example, if you're using Windows, Rust tries to build an .x86 example that uses 8664 instruction. This environmental folder host system. To describe different environments, Rust uses a string called target triple. Okay, target triple. If you don't specify the target, okay. Let's see. You can see target triple of your host system by running Rust C version verbose. Above output is 86 Linux system. We see that the host triple is 8664 unknown Linux triple. It is quadruple 1 2 3 4, which includes CPU architecture, the vendor known, the operating system, and the ABI. Why is it called triple then? RUS. Unknown vendor. CPU architecture. Vendor, the Linux GNOME. CPU architecture, vendor, operating system, and ABI. Interface between two binary program modules. API, system call interface. API stability is guaranteed. Source code is portable. API stability is not guaranteed. Source code portability is not given. Kernel internals. Kernel to user space. ABI Linux OS Alpha Bravo Charlie. Motion builder my etc. What is this? Compiled against 5.04 8664. Compatible ABI can be guaranteed. Binaries are portable. No stable ABI over Linux kernel releases. Binaries are not portable. Binary device driver compiled for Linux kernel 3.0. इधर चलेगा. So basically this is for binaries application. By compiling one host to pull Rust compiler and the link version. Okay. As an example of such bare metal target is the Thumb V7 triple. Okay, so this is a CPU architecture, Thumb V7. None is probably. All that matters is that the target triple has no underlying operating system, which is indicated by none. No OS and extended ABI hardware float. To be able to compile for this target, we need to add it in Rust. Target add this. This downloads a copy of the standard and core library for the system. Now we can build our freestanding executable for this target. cargo build target. Nice. Okay. Okay, I'm thinking doing something that I remember from embedded Rust, but I should not do this right now. We're passing a target argument, we cross compile, okay, linker argument. Instead of compiling for bare metal, it is this is the approach that we will use for building our OS kernel. Instead of this, we will use custom target that describes 86 bare metal environment. Oh boy, 86 bare metal. Oh, I remember. Yes, it does. Details will be explained. Okay. Instead of compiling for bare metal, it is also possible to ignore the linker errors by passing a certain set of arguments to the linker. This isn't the approach that we will use for our kernel. Therefore, this section is optional and only provides for completeness. Click on the linker arguments. How do we do that? The problem is that a linker includes the startup routine of the C runtime manifold, which is also called the start. Comes from assembly. It requires some symbol of C standard library due to this. Okay. No start files. The underlying Nest compiler has the flag which passes an argument to the linker. Combined, our new build command looks like this: cargo rust C. Now our crate builds as a freestanding executable on Linux. We don't need to specify the name of our entry point functions explicitly, since the linker looks for a function with this name. Okay, so in summary, don't link standard library, disable all the Rust level entry points. Don't mangle the name. This function is entry points and the linker looks for a function named start by default. Function is called on panic since cargo.toml about. There is a broken link which isn't actually formatted as nice. Hmm. I know that. Okay, so what I was looking for um, is this exactly. So even though my code compiles this, but my music is stopped. Shoot. It is NCS, right? Created by Chiano or have the permission to use. Okay, I'm not going to use it. भैया 4K में नहीं चलाना है हमको. We will check this clear instruction about my music. Also the safe to use the background music for original work. Nobody will stuck your video. In case you need to monetize the video using my song, just contact my label at. I'm not going to monetize anything. My music is safe to be used in seems like it. Okay, so what I was looking into was this. Even though my code compiles, but this thing is not going away. The problem is like this guy said. This guy, you were getting the error because Cargo thought you were compiling to this. But you are not, like you said this. That's why it's saying that it is duplicate, because Cargo thought you were compiling for that target, that 86 target, and all those. With that comes a panic handler, I suppose. And now you have defined another panic handler. So either you delete this or you tell Cargo to look for, or you tell Cargo that there is no 86 target. For that you have to give this target JSON, which the blog will show you in later post, which we'll be taking a look into. Basically, see, yeah. So that error will be gone. It's not exactly error because just Cargo thinks differently. So this is the. I'm thinking, should I end the stream or not? Or not now. Let us say here we are. So this is done. Minimal Rust करना. Yes, in this post we create a minimum 64-bit Rust kernel for 8-bit architecture. Thing is, I come from embedded, but I work with ARM. ARM is much simpler in as compared to ARM is RISC, right? Reduced instruction shells, reduced instruction set computing, and it says it's complex instruction set computing. So 86 architectures instructions are, or I don't know them, that's why they talk. I don't know. So how long is this? Cool. So there is this boot process. I mean, I can skim through it really fast, but I feel like I should. The boot process, boot BIOS. See, this guy is just God. UEFI minimal kernel didn't provide support. I don't think we need Rust nightly now because installation. I highly recommend Rust up. Allows us to opt in with experimental feature used by so-called feature flag at the top of our pipe. For example, we could enable experimental ASM. ASM actually I think is being stabilized for inline assembly by adding some to top of our main RS. Note that such experimental features are completely unstable, which means that Rust future Rust versions might change. Okay. Target specification. So this is a target triple. See, it was for a target system. However, we require some special configuration parameters or no underlying was. So none of the existing target triple fits. Fortunately, Rust allows us to define our own target through a JSON file. JSON. For example, a JSON file that describes the looks like this. The LLVM target, this data layout, and let me see if it makes sense to me. No, it doesn't. Architecture, target engine, little pointer width, C integer width, OS is executables true, linker flags, linker flavor, GCC, pre-link arg, more stack. Only thing that I don't understand is this data layout. Most fields are required by LLVM to generate code for that, and LLVM is for example, the data layout field defines the size of various integers, floating points, and pointer types. Then there are fields that Rust uses for conditional compilation, such as target pointer width. Then there are fields that Rust uses for conditional compilation, such as target pointer width. The third kind of field defines how the crate should be built. For example, pre-link args field specifies argument passed to the linker. Man, where does he get all this information, man? The pre-link arg field specifies argument that passes to the linker. Pre-link arg, what is this? Field space. The third kind of field defines how the crate should be built. It's officially Diwali, boys. Happy Diwali once more. We also target 86 system with our kernel. So our target specification will look very similar to the ones above. Start by creating an 86 block host.json file. Choose any name you like. Of course I would. Note that we change the OS in the Towergate. Change the OS in the LLVM target and the OS field to none. Because we will run on bare metal. We add the following build related entries: ld.lld, linker, rust lld. Instead of using the platform default linker, which might not support Linux targets, we use the cross-platform linker LLD that is shipped with Rust for linking a kernel. Panic strategy. About this setting specifies that the target doesn't support stack unwinding on Panic, so instead programming should abort directly. This has the same effect as the option in our cargo.toml, so we can remove it from there. Note that in contrast to cargo.toml option, this target option also applies when we recompile the core library later. This post. So even if you prefer to keep cargo.toml option, make sure to include this option. Disable red zone. We are writing a kernel, so we will need to handle interrupts at some point. To do that safely, we have to disable a certain stack pointer optimization called the red zone, because we would cause stack corruption otherwise. For more information, see our separate post about disabling red zone. Red zone is an optimization of system 5 ABI that allows function to temporarily use the 128 bytes below their stack frame without adjusting the stack pointer. Image shows the stack frame of a function with n local variables. On function entry, the stack pointer is adjusted to make room on the stack for the return address and local variables. This one. The red zone is defined as the 128 bytes below the adjusted stack pointer. The function can use this area for temporary data that's not needed across function calls. Thus, the two instructions for adjusting the stack pointer can be avoided in some cases. Two instructions for adjusting the stack pointer in small leaf function. I don't have any idea about this. However, this optimization leads to huge problems with exceptions or hardware interrupts. Let's assume that an exception occurs while a function uses the red zone. Exception that is to right. CPU and the exception handler overrides the data in the red zone, but this data is still needed by the interrupted function. So the function won't work correctly anymore when we return from the exception handler. Take weeks to debug to avoid such bugs when we implement exception handling. Alrighty. Field enables disable target features. We disable XMSC features by prefixing them with minus. and enables soft float feature by prefixing them with plus. Alright. That there must be no space between different flags, otherwise LLVM fails to interpret the feature string. SIMD, MMX and SSC, single instruction multiple data. Data pool, instruction pool, vector unit, single instruction multiple data. I have no idea what that is. I mean, I have heard people using it and it is very fast. So putting it all together, this is our final thing. I think I should do this. Where was that? Okay. Mostly CPU architecture, unknown what. Something was unknown, which is OS vendor, I guess. Zero OS, the API, yes, this is vendor. Data layout. Did he explain data layout? No. That's the name of the file. x86-64, okay. x86_64 booyah.json. Yeah, this is your target, is this, data layout is this, architecture little endian, pointer to 64, OS none, linker flavor ld.lld, linker is unity, panic strategy, red zone, disable red zone, feature is soft float. That's it. So we are not supporting SIMDs, okay. And I can remove panic. Where is panic strategy support? So I can remove this from there. Language that I require for a personality. I forgot. Cannot find create core. May not be installed. Consider downloading the target first. Okay. So it cannot recompile it to core. I remember. This compiler no longer finds the core library. This library contains basic Rust packages. Okay. Problem is that the core library is distributed together with the Rust compiler as a pre-compiled library, so it is only valid for supported host triples like these ones, but not for our custom triples. If we want to compile core for other targets, we need to recompile core for this target. God. To use a feature, we need to create a local cargo configuration file. And stable. It should recompile core and built-ins. The latter is required because it is a dependency of core. In order to recompile these libraries, Cargo needs access to Rust source code, which we can install with Rust component and Rust SRC. Config.toml. What else was there? Component address SRC. Is up to date. Okay. Required sized line items. Cannot find core. That's where the feature of Cargo comes in. It allows to recompile core and other standard libraries. Creates on demand instead of using the precompiled version shipped with the. This feature is very new and still not finished. It is marked as unstable and only available on Rust Nightly. We do need Rust Nightly. Unstable.build as standard configuration key requires at least a Rust Nightly from 2020. Looking for Rust Nightly. Start attribute. Rust C. I'm looking for Rust nightly. Anywhere, boy. किधर है भाई? घंटा ownership standard, no standard. Cargo build, personality, engage item, disable unwinding, cargo build, start attribute, runtime CRT 0. Welcome that we don't want to use normal dependent. Okay. No mangle, make calling convention, cargo build. Where is it? See runtime, solve a problem in runtime. Bare metal. Up. Rust C version. I think it's in the host to BIOS boot install nightly. Oh boy. Rust 3 is okay. C version. I recommend Rust is with Rust you can use a nightly compiler for the current directory by running Rust overrides at nightly. Alternately, you can add a file called Rust toolchain with the content nightly to the project's root directory. You can check that you have a nightly version. Okay. Rust toolchain nightly in the content. I would go by this route. I just toolchain. Oh, nice. Panic handler and all these are handled. Good. Booyah. Wait a second. Build standard. So we are we building standard library? Compile the standard library itself as a part of the create graph. See, it is building the standard library. This feature has also historically been known as standard aware cargo. This feature is still in very early stages of development and is also a possible massive feature addition to cargo. Possible. This is a very large feature to document, even in the minimal form that it exists in today. So if you are curious to stay up to date, you will want to follow the tracking repository and its setup issues. Okay boys, so we start tomorrow from here. We'll start from here, memory related intrinsics, whatever. Okay, see ya boys, bye bye, tata, see you tomorrow. Yes, tomorrow.